Hello everybody. So in this video I am starting a new chapter number 4, structure of atom. So basically in this video I am going to start with uh, basically in this video I am going to discuss about atom. What is the structure of atom? So Dalton say that atom is atom is the smallest unit of matter. There is a question, is it so? Is it so? Atom is the smallest unit of matter. But after some time, uh, some scientists some scientists say that atom is also further divided into there are three subatomic particles of atom are electron, proton, and last is neutron. So in this chapter we are going to discuss about these three. These are the subatomic particles of atom. So let us first talk about the discoveries of these three subatomic particles. First, electron. Electron was discovered by scientist J. Thomson. Proton. Proton was discovered by the scientist E. Goldstein. And the last, nucleus. And also in 1586 proton was discovered and neutron was discovered by James Chadwick. So let's if further go, electrons are negative charge particles. J. Thomson state in his experiment that electron are negative charge particles, whereas proton are positive charge particles. So let's talk about the scientist J. Thomson. So what do you think? What does this man did? So this man did that he said that whole sphere like structure atom is positive charge and electrons are embedded as seeds are embedded inside watermelon, and he said that the whole nucleus is positive charge. So these were the theories of J. Thomson about electrons. So I again repeat, electron whole sphere of atom, sphere like structure of atom is a positive charge and nucleus is positive charge and electrons are embedded in it as seeds are embedded in water. He compared his theory with watermelon. And if we talk about now, let's talk about the next scientist, Rutherford. The nucleus of atom is positive charge and the mass of atom is present in the center of the atom. And he also said that electrons revolve around the nucleus. And we will also do the limitations of these scientists. So these are the electrons. According to Rutherford, the mass of whole atom present at the center of atom, and this nucleus is positive charge, and all the electrons, these are electrons, and they revolve around the nucleus. These so let's go further on the next scientist, Bohr, Neil Bohr. He is a famous scientist and also given a lot more about chemistry and plays a vital role in chemistry as he changed all the view of the of atom, as he discovered the he said that electrons revolve in a discrete orbit, and electron do not radiate energy. So he named the cell as K, L, M, and N as the energy levels. So the number of electron K is having is 2. So the electron, so how will the electron present? So like 2. 2 are there in K shell, and for that 8 is common. So in L 8 are there, 1, 2, 3, 4, 5, 6, 7, and 8. So if they are same in M and N also, 8 are there. And let me know you more also give a formula to n square for finding the number of electron present in a particular cell. Let's suppose let's suppose if we take a K cell. K cell is a number one cell. So K number one cell. So 1 का square 1 होगा, और 1 into 2 is 2. So number of electron are 2. Let's take L. L is a second shell. So 2 and square 2 at the, so 2 is placed. 2 square 4 into 2 8. Number of electron are 8, but it is failed after M. It is failed. This formula do not works on other, and these are like Bohr is also having limitations. So let's talk about the limitations of these scientists. Let's talk about the limitations of the J. Thomson and Rutherford. And limitations of Bohr are also there, but in class 9th there is no limitations. The limitations of Bohr are that how much shells are there. It do not tell about more than n number of cell, and there are 2 or 3 limitations are there. But if we talk about these both, J. Thomson and Rutherford, they are there in class 9th. So let's first talk about J. Thomson. Limitations of J. Thomson are that he said that first, could not explain the results of Rutherford scientist. So he could not explain the results of the Rutherford, and also he said that first point. Second limitation, he said that there is no nucleus. There is no nucleus in atom. He said that there is no nucleus in the atom. And at the last limitations is, he said that electrons are emitted in an atom. So how can positive and negative charge remain together? How it is possible? So how could positive and negative charge remain together? How it is possible? And if we talk about Rutherford, so that electrons revolve around the nucleus, and nucleus is positive charge and electrons are negative charge. So it is clear that. So how could how electron so why electron do not lose its energy? If electron do lose its energy, why they do not collapse to nucleus? The question came. This is a limitation of Rutherford, and the main is that is also this is only, and he could not also explain the stability of atom and stability of atom, stability of electrons. He could not explain. So these are the limitations of both the. If I ask you a question, what is valency? What comes to your mind? So valency is the lose or gain of electron by the atom to stable or to have to complete its octet in outermost cell. This is called valency. So you need to know what is valency before learning about the electronic configuration. So you have learned this in chapter number 3. So I again revise. Let's suppose valency of sodium. So sodium atomic number is 11 atomic number. So first case has 2 KLMN. So 2, 8 and 1. So I ask you a question. What is easier, to lose one one electron or to gain 7 more electron? So obviously to lose 1 electron. So the valency of sodium is 1 plus 1. So let's take a different one. Let's take oxygen. So atomic number of oxygen is 8. In K shell 2 and 6. So it is easier to gain 2 electron, or it is easier to lose 6 electron. So obviously it is easier to gain 2 electrons. So -2 is the valency of oxygen. So you have to practice more about these questions. So let's talk about the electron configuration. So now I will tell you some most important topic of this chapter. So atomic number equals to number of proton. In short, I will write number of proton, and mass number equals to P plus N. So we can find atomic number by subtracting n from the mass number. So this is all about the valency, like electron configuration in isomer. So atom of a same element having same atomic number but different atomic mass, so they come in the category of isotopes. So atom of a same element having different atomic number but same atomic mass. So how you're gonna learn this? you can use a trick. In last bar is there, bar something related to weight, so you can learn like this. It is very confusing if you remember for a long time. So let's take an example. Let's take an example of hydrogen. Hydrogen. So there are three: protium, deuterium, tritium. So H is same in the symbol is same, but atomic number is same. Atomic mass is different. 1, 2, 3. Atomic mass is represented by Z, and atomic number is represented by A. And if you talk, if example of isobar are argon and calcium. So calcium, argon mass is both 40 and 40. But I said atomic mass is different, 18 square and 20. So this is the difference between isotope and isobar. And the applications of isotopes are so applications of isotopes are an isotope uranium, uranium 238. 238 is used as to determine the age of old born of living organism. And an isotope of U-131 is used as a treatment of goiter. And carbon 14 is used as a treatment of used to determine the age of earth. So this is all about the applications of isobar. So from this chapter is over. We have covered all the topics of this chapter: atoms and molecules. Structure of atom. So this is all about this chapter. Very interesting chapter. This is not the learning chapter. You have to understand this atomic number. You have to learn some example of isotopes and isobar, and do not forget the difference between isotopes and isobar. So this is all about this chapter, structure of atom. Thank you so much uh, for giving your precious time to me. Thank you so much, and watch my video, subscribe the channel. Bye bye.